And then we can mount the fan on the ceiling and
I
have
moved it, but because he asked me to, because he's crippled and I can't.
That's sad. Don't do that
Who's
to
the
her.
tallest person you know?
She was there first.
Yell me.
I had a classmate that was
Okay, we're supposed to take this.
6'9", 6'10".
Who?
She wants to be
Justin.
one of her friends at least.
He lives in Ventura. It's not everyone. He's really tall. We had a lot of tall kids in my class.
Like you?
Yeah, we're all short. It's no joke.
We are.
How many kids are in your graduating class?
34.
Oh, that's not bad.
Here, after crippled,
Also,
stop
you
being
can
crisis
that you
That's a
have.
lot of kids. That's like,
Yeah.
that's similar to what Fred is.
Better get up, buddy.
It was big for us all Ventura.
What was a small class?
He gets the worst. Obviously,
Okay. Alright, hey, real quick, there's a reason why I want your book open. I want you to take a look at the types of problems we're going to be doing today. So, hey, not today. If you take notes. Alright, now. Okay.
That was good. Oh my goodness.
Now you're going to do that. Alright, now, hey, okay. In the book, the big thing they want you to look at is take a graph, go to a formula, or go from a formula to a graph. We need to practice this because if you notice, a lot of the problems, almost all of them, have a horizontal shift, and I never had you do any of those in pre-calc. So we need to make sure that you know how to do it today. I'm going to try to show you the shortcuts that I have, but on Monday you are getting an assignment. You're pretty much looking at what page you're on. So what we're going to do today is we're going to pick problems right out of your book, so you might get freebies today for the homework, and I want to just make sure that you understand how to find it, okay, and how to do these types of problems. Okay, here we go. So, I'm going to
609. Free of charge. I did it in one period. And an outline first, and then I wrote 609 words on my essay. And I did Spanish before that.
609 in one period?
And I did Spanish before that.
I don't have that focus.
I have been working on I don't have that kind of focus. I don't have that kind of focus. I went out on 137.
Well, I started today. I got a topic 2 periods ago. Started.
So Tuesday I wrote 68. Since Tuesday. You should have run
I want you to know.
You should have run one
You
now.
guys are moving your stuff all the way to the front.
I did.
And James and I bullied him.
Okay.
Frankly, me about.
Okay, real quick.
I got up, punched him
Hey,
out.
all right. First row right here, you guys, my first, I guess, column or row here. I want you guys to pick a problem on that page 42, the one where they give you a formula, and we're gonna go graph it. Okay, so preferably it would be like between 10 through 13 in that
Wait,
range.
put those two?
Even.
No, any of you guys.
Make it even number.
Here's any of us.
Any of you guys. 10 through any of you.
Wait, what are the
Make it
options?
even number.
10 through 13.
Because the odds are in the back, so
That's
if
the number
we
in
even
the
number means more homework than he's doing for us.
We want 12. 12? Is that the tough one? Okay. 12.
W equals 8 minus 4.
Okay, hold on. Alright. Hey, I would definitely write these down. These could be freebies for the homework. That when we get it on Monday. Okay, say it again.
W equals 8 minus 4, and then sine, and then parentheses of 2x plus pi.
Plus 5?
Yes, and then pi. Sorry, I thought you said pi.
Okay.
There you go.
Okay, alright. Now, this type of problem, what we're going to be looking at, it does have a vertical shift. It does have an amplitude being affected, it does have a period, like the frequency of it being affected, and it's got a horizontal shift to it. Now, to figure out what these are, figure out how to do it. Number one, what I would focus on first, I would focus on the horizontal shift to figure out where that first hash mark is going to be. So what I would do, take the 2x plus pi and set it equal to 0. Question. I need to figure out where this thing is going to be the new origin. Where will it hit 0? Because normally our graphs we start at 0, correct?
I'm doing good.
But we start at 0 and we go from there. This has been shifted. To figure out how they shifted it, you set this part right here equal to 0, and that tells you where the new starting point is to draw my sine function. Because we already know what sine function looks like. It should look something like
Pi
this.
over 2.
That's what sine should look like. Generic.
Negative 5.
Okay.
Oh, sorry
So,
guys.
and yeah, we're gonna do negative. Now, to do this, you guys are already saying it, we can go negative pi over 2. That number is the start. That's gonna be right here. Negative pi over 2. That's the start. Now, I have no idea how far down the road that was. I'm very generically just putting that right there because I know it's been shifted to the left on negative pi over 4. Or sorry, negative pi over 2, sorry. All right, now, to figure out where the hash marks go from there, this is the part that's tough. This is the only real challenge of this problem, is this part right here. Normally, we go out to 2 pi, right? That's normal. That's normal. We go out to 2 pi.
7 pi.
We are not going out to 2 pi in this problem. We are going to go out to whatever 2 pi is divided by the number in front of your x.
Silence.
It's always the same. So, question?
Silence.
2 people died in North Carolina because of the hurricane. Just now.
No, we had to have more silence.
Two more. Two people dying.
What did they say? But why is it 2 divided by 3?
Trying to get that.
Make this 5. Trying to move this along.
No, they're making this impossible.
Hey guys, shut up!
So,
There we go.
normally we go out to 2 pi, but in our case, we have to divide by the number that's in front of x. So, we're actually going to be going out to pi for a final distance. Now, I don't want you to mark that yet. Why we do this? This is going to help me find what my spacing is between all the hash marks. So, I normally go out to 2 pi, but now since we divided by 2, we're going out to pi. We go back 4 hash marks like we always do. Always goes back 4. Now, the reason I'm having you do this on the original picture is because I need to know what the first hash mark is. The first hash mark is actually the most important hash mark that I have because it actually gives you space between all the markings. Okay, that's something that a lot of people don't think about. The first marker is the most important one. So if we're going out to pi, we have to go find the first marker. We have to divide by 2, divide by 2 again. There is the most important hash mark we have. Pi over 4 is the number we needed. That number is the spacing that I'm going to take to go from here to the next marker. And whatever the next marker is, and the next marker, until I get one full picture done. Now, how do I know where to put those markers? You have to start adding. So wherever this starting point is, we already figured out it was negative pi over 4, or sorry, negative pi over 2. I'm gonna put this over here. We knew that we're starting at negative pi over 2. What we're gonna do is we're gonna add that spacing that we did every single time. So we're gonna add pi over 4. And we're gonna keep doing this one at a time until we find out what all the hash marks are going across. You need the starting hash mark and always 4 after it. That's how it always works. 1 hash mark, 4 after it. So I already have my starting point. I need 4 lines after. Now where they're going to be is going to give me right here. When I add that spacing. That's why this is important that I have to go find that original one. So I'm going to add pi over 4. Now, we have to make common denominators, right? To add these together. So I'm going to make this, I'm going to multiply by 2 here. So this is going to turn out to be a 4, multiply the top by 2. Now I can add straight across. When you add, I'm going to get negative pi over 4. Because this is negative 2 plus a negative, or plus a positive 1, which is negative 1 pi, and then that's over 4 because when you add, you don't actually add the denominator. So that's this marker right here.
You just do?
Pi fourths, sure.
Oh.
Negative pi fourths.
I don't think I've ever.
Okay, now I made mine a little small. I'll probably make this a little bit better looking once I kind of know where the hash marks go.
Is it
and
necessary
usually-
to write that one down?
What?
Do I have to write that one down?
Write this down so you know where the next
Well,
hash marks be. You don't have to be drawing the picture yet because we can fill in the picture
already
so it
did.
looks better.
Well, like, I just don't have enough room to write it.
Oh, just wait on the picture for right now. I'm doing a very generic picture right now. I'm gonna make this look a lot better once we get going. Now, this is this marker right here. I still have to go 3 more. So what I have to do is take this next one, negative 1 pi over 4, and add another pi over 4 to it. Because every single time I have to keep adding this number to get to the next hash mark.
So it's 0 pi.
So it's gonna be 0, basically, because you're gonna get, this is gonna be negative 1 plus 1, which is 0, divided by 4, which is still 0. That's actually where I have my hash mark. Kind of knew it was gonna be 0 before I started. Now, Keep going after that, we're gonna add another pi over 4. So we're gonna take 0 and add pi over 4.
Oh, jeez.
Well, that's easy enough. Pi over 4.
I just need a, I'm kind of going slow here.
So all I'm doing is taking that first point we started with, the one that we found earlier, and just adding my space to it every single time. And I'm just putting those numbers down on the graph.
Okay.
So this is the first marker we found, this is the next marker.
Okay, I'm good now.
There's the third marker. So that was pi over 4. And then the last one, you have to take this pi over 4 and add another pi over 4 to it. So if you add that, you're going to get 2 pi over 4, which is pi over 2.
You don't need that one.
You need at least the 5th one down the road, because you have the first mark and then 4 hash marks after it. Okay, now I'm going to make this look a lot better. But that's how I get my hash marks. Now, I already kind of knew where they're going to be. You probably won't, because you're going to be, adding. I would not probably draw the picture, like the generic picture, until I find all of those hash marks after the first one, the next 4. That way you kind of know where to put them. Is it on the negative side? Is it on the positive side? Where are they going to be? All right, we're good so far?
Addition signs not
All right, next, I'm going to make this picture look a lot better because right now it's kind of messy.
I think it looks good.
I think it looks good too.
All right, well, we'll leave it then if you guys like it. Now,
No.
okay, next, we have to work about shifting this thing up or down, right or left, because we already got where all the hash marks are. So the next thing we have to look at is usually this 8 is in the back. It's usually in the back behind the parentheses. So we can actually write this problem like this.
I'll give it a word tonight.
So close, too. I feel like the
Okay,
more
so if I put that in the back, what does that plus 8 mean?
I went to bed.
That's where the line is.
Yeah, it's been shifted up 8. It's a positive 8 in the back. I just moved it to the back. You don't need to do that. I always like the number in the back. That's just easier for me to see. So this thing has been shifted up 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's 8. Now, what we're going to be doing from that 8, that's my origin line. This is the positive 8 on that graph.
We gotta go up.
We have to go up and down from there, because that's the midline. That's what I call the origin line. We have to go this number above and below it. So we're going to be hitting 1, 2, 3, 4, and going up 4 from there.
It goes to.
That's what, 12?
Okay, I'm gonna go.
I would do that.
So, drawing a better looking picture, here's what we have. So if this is my better looking picture, let's say this is my number 8, going down 4 from there, going up 4 from there. So drawing, I'm like focusing in more where my drawing's going to be. My 4 hash marks going across.
Not like this, but
I guess my 5, I should say, because there was one in the middle here. But this is going to be my negative pi over 2. This is negative pi over 4. We already had 0. We had pi over 4. We had pi over 2. Pi 4. All right, now we're going to be drawing my sine graph. The only difference is my sine graph's negative. So if there's a negative sign out front, instead of going up and down like it normally does, I'm going to go down and up. I'm just flipping the graph over. So here's what it's going to look like. This is the starting point. Instead of going up and down, now I'm going down and up. There's your sine graph. There's your graph. We need to get used to all this stuff. This is tough. Like, it's a lot of steps. It's a lot of processes where you have to like figure stuff out. You got to figure out where to start, where to go from there. It really depends on whether you know, like you really have to know how to draw a sine. Like the original one, like everything about it. What the 4 hash marks are, where it goes, what the general graph looks like. But then you got to put in all the other stuff. Amplitude, period lengths, where the hash marks are, shifting up and down. It's a lot. Especially negatives, knowing that it was upside down. All right, questions, comments about my graph? That was only one period length. I could keep going and keep adding more pies.
These are hard problems.
Yeah, these are not easy. Like, it took a definite leap from pre-calc. Pre-calc, you learn the basics. Now we're plugging it in for real.
How did we go from like a regular sine graph to...
I think that's about all you can do.
How does ball formation?
So that's
Where it
like the-
shifted is because of this. When they add and subtract numbers in here, it shifts it right and left. So that's what we did in the very first step. We had to figure out how did they shift it. We set that equal to 0, and that's where it's now started. That's that first marker I made. It's whatever's in the parentheses you set equal to 0. That tells where it starts, and then you draw the graph from there. Yeah. Okay. Let's do another one. So that was the first group. Nicely done. Second group. Let's go over to the next page, page 43. And I believe, no, actually, sorry, still on page 42. No, it's the numbers 27 through 30. I just want one of those.
30. 30.
Or 30.
30?
This is what they need to
Let's do 30. All right, here we go.
You figure out what we
Okay, hey, does everyone have that problem written down?
Yeah. Yes.
Okay, we're gonna do another one exactly like it, hopefully. Is it cosine or sine?
Tan.
Oh, tangent, okay, that's fine. We'll do tangent.
Oh. Is that a good thing or a bad thing?
We need to review tangent before I start.
Big ones.
All right.
Not just normal ones, but big.
Okay, hey, real quick, let's review a tangent function before I start. If I ever had to draw a generic tangent function,
Nicole, what number is this?
This makes math fun.
30.
okay, we're gonna do 30 here in a minute.
But this
We
is
need to talk about how to draw tan in the first place. Tan is the only weird one that's centered over the origin. So it's like this. It's centered over the origin. Now tangent has a different period length, the frequency length. Instead of going out to 2 pi, it goes pi instead. And that's the whole picture. It's all pi. The whole thing, from beginning to end, it's 1 pi length. So what you do is you split half over here, half over here. So half a pi is pi over 2, negative pi over 2. And then you cut those in half again, which is pi over 4, negative pi over 4. And then the idea is that tangent has asymptotes. Bless you. So tangent has on the outside markers, it's definitely, it's got asymptotes, beginning and ending. It's gonna go through the origin, and where I know it always hits, it's gonna hit 1 and negative 1, just like sine and cosine. But as it does this is the only one that doesn't do a wave. It's doing more of like a, how do I explain it? It's more like a cubic function loop. It's got a curve to it, where it does this. Starts in the upper corner over here, loops down till it hits 1, then it goes down to 0, then it goes down to its negative 1, and then it goes down to negative infinity. It kind of looks like a cubic graph. Loops down. Because again, tangents, it's infinite in range. It can go up to positive infinity, negative infinity. It's just the domain is limited. What you can plug in. All right, that's a generic graph. Now, number 30, please.
It is 1 equals
Tell her Riverdale.
8
Tangent. Is it told her? I think it's told her.
parenthesis 2x plus 1 parenthesis minus 3.
What is it?
I got you.
8 tangent.
Well, yeah. Just let me look it up.
I swear he said.
No.
Okay. All right. Now, this one has different instructions. We're just going to graph this one like the other one. The instruction on this one said, hey, find where the trig function equals that value 1. So you have to go find the number on the graph where it actually hit 1. We're going to just do our normal thing where we graph it. Okay, let me stop the camera here so we can get the whole thing in it. All right.
Okay, we'll do it in
Okay, first, I'm going to move the 1 to the other side. I like to get 0 on the one side so I can basically set f of x equals, if I move the 1 over, I'm going to subtract it, so here we go. Tan 2x plus 1 minus 4. As I move the 1 over, it became a negative 4. We're just going to graph it like normal. this is how I attempted that problem that you guys did yesterday in here, where I said, hey, find where this trig function equals this value. I said you guys could use a calculator. It's the same idea here, where you can move numbers over and solve for x and do inverse tangents and stuff in your calculator. But we're going to graph it and we can still find the same value. Okay, so we're going to graph this thing. So now tangent normally does this stuff. It's obviously been shifted right and left, so we got to go figure that out. We got to figure out where the new center of the graph is. Then, once we have that, we can figure out where the markers are. And when we have the markers set up around that picture, then the idea is that then we'll shift it up and down and affect the amplitude. Okay? Alright, so let's figure out where it starts first. Exactly. So, say equals 0, 2x, -1, divide, boom. There is the new center of my graph. It's not at 0, 0 anymore. It's now at -½ Does everyone understand that?
Yes.
Okay, now again, let's not draw this right away. Let's do it like we normally would, so we can set in all the numbers later. So that's gonna be my starting point. In fact, I'm gonna label that. This is the start, or the center. Yeah, we'll do that. That's my center. Now, what we need to do next is we need to figure out the spacing where the hash marks are going to go. Normally it goes total is pi across, and we cut that in half, and that's the spacing. We need to figure out that spacing. So what we need to do first is take pi. That's its normal period or frequency length, and divide by the number that's in front of your x, pi over 2. So it's, because tangent's always pi in length, not 2 pi like cosine or tangent versus cosine. So if it's normally pi, we're going to divide by the number in front of x. This is giving my total frequency. And so what that means is I need to go find the hash marks from there. The whole distance across is now pi over 2. It's not going pi, it's going pi over 2 all the way across. So we cut it in half, which is pi over 4. Cut it in half again, which is pi over 8. Does everyone understand how I got that?
Yeah.
Take the whole distance, divide by 2, divide by 2. So my spacing is pi over 8. That's the spacing. That number is important. That will help me find where the hash marks go on my graph.
How did you do that? Can you explain again?
Okay. The whole distance, whatever it is, normally it's pi, but in our case it's pi over 2. So, because we take normally pi, whatever the number is, and divide by that number. So what we do is we take this number, which is in our case pi over 2, divide by 2, divide by 2 again. Figure out the 4 hash marks. And so mine is going to be pi over 8, divide by 2, divide by 2 again. So that's the spacing. So from my center, I'm going to go right pi over 8, right pi over 8, and then left pi over 8, left pi over 8. And I'll just add and subtract them. So this is the math I'm going to do off to the side. So again, if I was on my notebook, I'd be doing this. Pi over 2, let's add pi over 8 first. That's going to go to the right. Okay. So this is going to, if I get common denominators here, make this an 8, multiply the top by 4. I add across. My first hash mark is 5 pi over 8. That's the first hash mark to the right. Because I added pi over 2 to the space. Oh, actually, oh geez, what am I doing? Hold on. What, hey, sorry, what's my center? That's the number we're at. Sorry. Yeah, sorry. Alright, so, apologies. Alright, what we had to do first, we had to add my spacing to where the center of my graph is. Now, this is the part where, like, if I was doing this on my calculator, I would be just typing in -½ -0.5, and add it to whatever pi divided by 8 is. And I would just write down the decimal, and that's where I'm going to put the hash mark at on a graph. So in fact, I'm going to type that in. So, just use one on the wall. I wish that thing worked, that'd be sweet. Alright, now. Okay, so I'm gonna take negative half, that's my center, add pi over 8. So negative 1 divided by 2, and I'm gonna add whatever pi divided by 8 is. And I'm gonna put that pi over 8 in a parenthesis just to make sure I can add it. So it looks like when I do this correctly, the number when I add pi over 8 is gonna turn out to be a negative 0.1073. So that's gonna be, if I were graphing this, so generic graph where this is at, negative halves over here. I went over to negative 0.1073. That's where the first hash mark is going to be. Then I have to add another pi over 8 to that, because that'll get me the next marker down the road. So if I add another pi over 8 to it, this is going to be 0.2854.
You understand it?
Okay? Going the other direction, I'm taking negative half, and now I'm going to subtract pi over 8. And so this is going to be negative 0.8926, subtracting it from the 0.5, and then subtract it again, and I get negative 1.28. So you can get an idea where the spacing is. Now drawing a better picture here. Drawing a better picture. What I have here is kind of my generic. I'm just going to draw the line, put my negative half in the center, put my couple hash marks around it.
That's lit. I swear daily.
Alright, so this is my generic graph. Now, we've shifted this graph. It went, what, down 3, down 4. So really, if this is where the x-axis would be, this number is negative 4 down. And I need to be able to go 8 above that and 8 below that. Because I've shifted my 0, 0 is like up here somewhere, and then we shift it down. So yeah, so if I go up 8,
Because of you.
that's going to be what, positive 4? Going down, 1, 2, 3, 4, 5, 6, 7, 8. That's going to be a negative 12.
Yes.
And the graph itself will have asymptotes on the outside.
You know what anecdotes are?
Yes.
Me neither.
Asymptotes on the outside. I'm going to start in the upper right corner. Upper right corner. Come down to the first marker. Come down to 0. Hit the next marker. And then go off and finish it.
Wait, or, I swear.
Because now, why I'm hitting those markers? I'm not going to hit 1 and negative 1 anymore. I made them 8 taller. So I have to be 8 from wherever the center is. That's where the markers are. So if I was hitting 1 and negative 1, sure. But I had to multiply those numbers by 8 and go from that center line. That's why the center line was negative 4. I had to go 8 above that. That's the first marker. And 8 below that, that was negative 12. So that's where my new 1 and negative 1 are sitting. It's whatever that 8 below and 8 above is. There's your graph. It should be a normal tangent key. But if you notice how I'm drawing it, I'm making it look like a normal x-axis. I'm just adjusting where the numbers are. The center isn't 0, 0 anymore. It was negative 4, comma negative half. Or sorry, negative half, comma negative 4. That's the center of the graph. Like, it's not an easy concept. Now, what your problem asked for was to figure out where your graph actually hit the number 1. Well, the number 1 on that graph, like if you're actually answering the question they wanted you to, the number 1 is over here. It's over here, and it's positive. So like 1 to make it 1 up here, it's like right there. You have to figure out where that graph's gonna be. It's gonna be like down here somewhere. This process is tough. It's like this type of problem is one of the hardest problems you can do. What? It'll hit 1 because this graph will continue over here. It'll do another one over here. And so the number 1, wherever this is, the number 1, because where is 1?
What are your dots there for?
What, these?
Yeah.
That's where I hit that first marker. Usually it's 1 and negative 1, and that first bend.
Yeah, but is it supposed to be equal with your negative .1073?
No.
Yeah, it's supposed to be kind of right there.
Well, because I was looking
Yeah,
at
it's supposed to be that first half.
Is it that you ain't got it?
Yeah.
I never do that. I always say
Okay. All right. Now.
I always say did
Hey.
I always say did
Okay, on Monday, when we come in, we're gonna take a look instead of these problems, because we're gonna try another one. Our folks on Monday, even though we're gonna try one or two of these, maybe one, we're gonna look at the other ones where they give you a graph, so you can see like number 14 through 23, and we're gonna try to figure out what the formulas are for the graph when the graph's provided to you. So we're going backwards.
Oh no.
This stuff is not easy. Like you need to like really hone in like what we're doing and how we're doing
So
it.
we need to focus a lot of time on just one problem.
Yeah.
Not
So
me.
test end of next week. Because after Monday, we're done with the chapter. We're taking tests probably Thursday and Friday. So keep that in mind. And it'll just go over the big stuff we did. I consider this one of the big things.
This would be a big thing.
This is a big
It's
thing.
large. Massive. Mr. Ward,
How
Mr.
good I love it,
Which one?
See, you know, I love collegiate.
Really?
So
It was
if you want
right next to the counter in like a little stand they had. And I didn't find it. Morgan Ryerson told me about it.
Oh, really?
She's like, hey, Ward.